So here what we want to do is map this region here onto an annulus. So it's the interior of the unit disk, but we've cut out a circle which is not concentric with that unit disk. So we call these two eccentric circles. Eccentric means they don't have the same center. Okay, so we'll use this transformation because we know that will take care of mapping this circle to this circle. We obviously want the interior to get mapped to the interior, so that means we have this additional condition that mod z0, whatever it is, needs to be less than 1. It looks like we want the real line to get mapped to the real line as well. Okay, so we can ensure that that happens by choosing psi equals 0 and z0 also real. So z0 needs to be real as well. Okay, that way you can see that this will be 1. If z is real, then we've got real minus real divided by real minus real. So this is all real. Okay. So what we want is that this point here is going to get mapped to either this point or this point, and this point here, b plus a. So we've got a circle centre of x equals b and its radius a. So we've got points. So f of b minus a needs to get mapped. So I've got w equals f of z. Needs to get mapped to either this point or this point, but the crucial thing is that it's minus where b plus a, the other point, gets mapped to. Okay, so I just plug those values in, and I'm going to call my z0 q. So z0 is q, just to have slightly less writing. So if I plug that in, I get b minus a minus q over q times b minus a minus 1 has to equal minus b plus a minus q over q times b plus a minus 1. Okay, so multiplying this by this, I'm going to get q times b squared minus a squared from this times this, minus q squared b plus a, and then I've got just minus 1 times this, so that gives me q plus a, sorry, plus q plus a minus b, and then that's got to equal this times this with a minus sign. So I've got minus q times b squared minus a squared. I've got minus q squared b minus a. Sorry, with a plus, so it's minus minus, so I've got plus q squared b minus a. And then minus 1 times this just gives me this plus this, so it's plus b plus a minus q. Okay, so I'm getting a quadratic in q. I just need to work out what cancels and what doesn't. So I've got b times q squared. This minus a cancels with this minus a q squared, but this, I've got over here, I've got 2 of those. So that's the q squared dealt with. Now what about what's multiplying q? So I've got minus 2q, and I've got a minus q times b squared minus a squared, and another minus q times b squared. So I've got minus 2 b squared minus a squared plus 1. Okay, so I've got two lots of q, just q on its own. And that leaves me with the constant term. So I've done the q's. I've just got a plus a minus b here, and so the a's cancel, and I've got plus 2b. So overall, I have this quadratic if I get rid of the 2's. Which I can then solve to give me q, and I write q plus or minus is minus b. So it's 1 plus b squared minus a squared plus or minus 1 plus b squared minus a squared squared minus 4ac, which is bb, so it's minus 4b squared over 2b. Okay, so I've got two roots. I only want one of these roots to be my z0. Crucially, I need that z0 is less than 1. So how do I tell which one is bigger than 1 and which one is less than 1? Well, first thing to check perhaps is that this is real. We expect this to be real. So we need this to be positive. So let's just check what happens if we expand this discriminant. What do we get? Actually, rather than expand, I just need to compare these two things. Is this bigger, this thing inside the square bigger than 2b? So if 1 plus b squared minus a squared is greater than 2b, what does that imply? So we've got b squared minus 2b plus 1 is greater than a squared, which I can rewrite as b minus 1. Well, it needs to be greater than squared is greater than a squared. So take the square root. So b minus 1 needs to be okay, that doesn't make sense. B minus 1 squared, which is the same as, obviously b can't be greater than 1, so that's the same as this, squared is greater than 1. Therefore, yes. I need 1 minus b is greater than a. Yeah, that makes sense, because you see 1 minus b is this distance here, and I need that to be greater than a, the radius of the circle, otherwise this circle will intersect this circle. So this makes sense. I'm consistent as long as this is true. Okay, so the next question is which one of these roots we need something which has modulus less than 1. I've managed to rub off the quadratic formula which I need. Here it is again. Sorry, no, b squared there. Dividing by b, I'll get that. This I can write as q minus q plus times q minus q minus. That's the reason for dividing by b. So this I can write, and this and this are the same thing. So if I expand these brackets, I get q squared minus q plus q minus times q plus, importantly, q plus times q minus equals 0. Now, comparing terms, the q plus times q minus is equal to 1. This is a very useful trick to know. So I know that q plus times q minus is equal to 1, which means that q minus is equal to 1 over q plus. So obviously the plus sign is going to be the bigger one. So that tells me that it's the q minus 1 is going to be less than 1. So I've now shown definitively that the q minus 1 is the one I want. So I've got my transformation now. The final transformation is w equals z minus q minus over q minus, it's real, so I don't have to worry about the complex conjugate, z minus 1. So q minus is given by this with a minus sign. If I want to work out c, it's rather a messy expression, but all I need to do is just do f of a plus b, and just to be safe, put a mod sign around that. So that will give me c, where f is this function here. So I just substitute this in. So it's a plus b minus q minus times a plus b minus 1, and just mod sign to be sure. It's just rather complicated to write down, and I don't think it simplifies in a nice way, but we can in principle find it.